Alright, in order to make our physics interactables throwable, we need to do a couple of settings on the interactors. So let's open up the OVR controllers first, and we'll see how we set up our physics based controllers so that we can throw the interactables. So let me create a game object and I will name it left controller physics. And on this game object, I'm going to add a couple of scripts. So first of all, let me search for controller pose. Okay, let me show you where the script exists so that you can find it, or you would know that this indeed exists in the package and not somewhere in samples project. Okay, as you could see, it exists in the Meta Interaction SDK. We also have a hand pose input device, but for the controller we will drag and drop the controller pose input device. It requires a controller reference, so make sure to give the appropriate controller reference. Next thing we need to add is a standard velocity calculator. So as you could see, this was the one we used previously for making throwables, and it has a lot of settings to configure. But now Meta has deprecated this and is asking us to use the ransack velocity calculator. So we are going to use the ransack velocity calculator instead. So search for velocity calculator and you should see the ransack. Yep. And now you can see there are no more settings, so no more confusions about what need to be configured, and just give the controller pose input device as a reference to it. The next thing that we have to do is that we have a velocity calculator, but we need to make our interactor aware of that. So in the interactor, open the optionals and drag and drop the velocity calculator onto the optional field inside the interactor, so that the interactor will know what physics or velocity calculator to use. Let's do the same thing for the right controller. Awesome. So once done, let's do the same thing on the OVR hands that we have. So we'll create similar game object, an empty game object called left hand physics, and we'll assign the hand pose input device instead of the controller input device we added to the controller. So this requires a reference to the hand, and we'll also add the ransack velocity calculator and drag and drop the pose input device for the ransack velocity calculator. Next thing again, we'll go to the hand grab interactor to let it know where the what velocity calculator to use. So drag and drop the velocity calculator onto the optional field on the hand grab interactor, and let's repeat the same step for the right hand as well. Awesome. Now we have our interactor setup. Make sure on the interactables, on the grab interactable, make sure you have the physics grabbable assigned to it, and the rigid body is set to use gravity and not kinematic. Alright, now we can test our physics throwable systems. So let's see if we can grab the non-physics. Yeah, it is indeed working. We can drop the physics one, but now it will also react to my flicks and my throws from the controller. Really great. Now let's test the same thing on the hand interactables. So we can grab the static one, we can place it anywhere we want because this is kinematic. And for the physics, it is reacting to the drop as previously, but now we can also flick it and throw it. Yep. Alright, now let's see how we can add distance grab interactions in our VR app. So which allows you to grab an interactable from a distance. So we'll add the distance interactor into our controller first. So in the controller group, let's drag and drop controller distance grab interactor from the project. So make sure to search for it in the packages if you don't see it. because this also exists inside the XR Interaction SDK, runtime, prefabs, and distance hand grab folder. Alright, so once we have it, let's drag and drop it into each of the controller group. So once we have it, make sure it reference to the correct controller. Then the distance grab interactor depends on few of the other scripts which we are going to take a look in a moment. So the first thing I would want to show you is the selector. Similar to the grab interactor, we have the same selector here. Then we have this distance candidate computer which uses detection frustum. So the selection frustum we'll take a look again in a moment. Then we have some optionals, and okay, coming back to the selection frustum, let's see what the script compiles. Okay, so the way this selection frustum works is that it has set of parameters which defines a conical shape around the HMD, I mean the center camera, and whatever interactable comes under that conical selection or frustum can be grabbed from a distance. So you can configure the cone from here using the settings. And then we have something called the grab center. So if you want to have your grab away from the like controller position, so you can use that offset. Now let's add the grab interactor, distance grab interactor to each of the best hover interactor group, so that they also get disabled and enabled when required. And one more thing that you would also need, I also want to show you, is to how to set up some visuals for the distance grab, because the ray interaction is the one that we have visuals for, but unlike the ray interactions, we don't have anything to showcase the distance grab. So now let's add a visuals game object under the grab interactor, and I'll create another game object called distant line. There are a couple of reasons behind the naming. So if we add component and search for only distant, so you would see there are three different types of visual we could add. We have a tube visual, we have a polyline visual, as well as a line renderer visual. So line renderer one is the most simplest one, and I think it works the best. So once you add it, it requires a distance interactor. So let's grab and drop the distance interactor. And it also requires a line renderer. So let's add a line renderer component on it. Alright, once added, so we need to do a couple of configurations on line renderer. First of all, let's make the width not from 1 meter but rather 0.005. So that means it will be 5 mm in width, which won't be much more larger in a VR app. I normally make the vertices and end cap vertices to 4 so that we have some roundedness and not jaggedy edges. Then make sure the alignment is set to view and not transform Z, otherwise you may see a flat line which is not desirable sometimes. The next thing that you want to keep a check is the world space. So always have the use world space checked unless you want the line renderer to appear in local space. And the final thing is to add a material. So for material I will use something called a sprite default material, which is an unlit material used for sprite. So make sure you select that. And other than that, yeah, everything else just leave it as it is. Let's drag and drop the line renderer onto the visual. Alright, so we have the right controller set. Let's do the same thing on the left controller. I'll just copy paste the same visuals again and set up the interactor. Alright, awesome. Now we got our controllers interactor set up. Alright, now let's see how we can add distance hand grab interactions for our OVR hand. So similar to the controller distance grab interactor, we have distance hand grab interactor. I'm not sure if the name was intentional or Meta forgot to update it to make it consistent with the controller distance grab interactor, but it is what you get out of the projects. Right. After dragging and dropping it to each of the group, make sure you update it in the best hover interaction group as well for the hands, so that it disables when it is not required. Uh, One more thing that the hand interactor, the distance hand interactor differs from the controller is that it requires a concrete HMD reference. Currently it's pointing to the building block one because it automatically picked that up. But we need to add on our own if we are going to do it manually. And it is also pointing to the same camera rig ref and the tracking toward transformer which we created earlier. If you haven't watched the previous videos, I do recommend watching them to know how we created that. So now let's create our own manual OPR HMD. You are welcome to copy paste if you have the OPR HMD from the building block, but just for everyone to learn how to create their own OPR HMD, I'm going to show you here. So after creating this, drag it to the top. I normally drag it to the top. You are welcome to keep it wherever you want. So let's add a script called HMD, not HMD ref, but HMD, because this will be our pseudo HMD that will follow our own HMD from our OVR rig. And let's add a data source for it. We'll name it OVR HMD data source. Alright, let's add from OVR HMD data source. And we will provide the OVR data source to be our own camera rig ref data that we created earlier. Also drag and drop the tracking toward transformer from the camera rig ref. Alright, once the data is set, now let's update the OVR HMD to use this new data source that we created, the child data source, and that will allow the OVR HMD to move along with our HMD without having to directly be a child of the camera rig, similar to how we set up the OVR controllers and hands. Alright, so once dragged and drop the data source, make sure to uncheck the apply modifier because we don't want to apply the data here, we just want to read it. So yeah, once set up, now let's move on to the distance grab interactor and update the HMD ref to use our OVR HMD, the manual one that we created. Alright, so once added, I think it's better to rename the OVR HMD to OVR HMD manual so that I can see clearly that the reference have been updated or not. Let me go back and check. Yeah, it is pointing to the OVR HMD manual. Alright, now let's see what the distance hand grab interactor requires. The first thing is the hand ref, which you can drag and drop from the top here. Then it requires a hand grab API, and as the name suggests, it uses or it determines the hand grab from the gestures. Then it also requires something called a head frustum, and this has a script similar to the conical frustum as well as a center eye offset. So this is where you can define a different offset. Normally we don't update it, but you can define a different offset to use your distance hand grab API because the hand requires the HMD ref to work with. Alright, double confirm the interactors group again, and we have our hands set up. So one more thing, let me add the visuals as well. Distance line, I'll copy and paste it from the controllers that we created earlier and update the interactors to use the distance grab hand interactor and not the controller interactor. Alright, now we have our hand set up to use the distance interactions. Okay, now that we have our distance interactor set up for both hand and controllers, let's add some of the distance interactables to interact with. I'll duplicate the non-physics group of interactables we have and move them into a different group called distance, and also position them farther side of the board so that we'll have some distance to grab from. Let's select the grab interactable first, and on the game object we are going to add another grab interactable script called distance grab interactable. So hit add component, then search for distance grab interactable, After adding it, so the first thing that you would see, it has automatically picked up the rigid body, but it requires a pointable element. So grab and drop the grabbable script reference there. And in the options field, we still have the physics grabbable reference if you want this to be physics interactable. So you can do that. But for now, I'll just leave it to be static rigid body. We'll do the same thing for the hand grab interactable. Search for distance hand grab and not distance grab. So keep in mind the name of the scripts, and drag the grabbable reference in here as well. Alright, so just to show you, the distance grab interactable does come up with the proper pinch rule setup, unlike the hand grab interactable, which by default doesn't has them set up. So I think Meta somehow missed updating these prefabs for hand grab interactable. So just to double confirm that each of the pinch and grab rules are set properly. Next we have the grab type or supported grab type, similar to the hand grab interactable. And finally in the optional we still have the physics grabbable instance here as well if you want or to use physics. The final thing that I'm going to do is to update the visuals to use the distance grab interactable. And once you drag and drop this, it will ask you to which grab interactable we want to have. So make sure you select the distance hand grab interactable for the hand grab, and same thing for the grab interactable as well. Alright, now that we have seen how we can add all the grab interactions manually, let's see the building blocks and what all interactions it allows us to use or add much more easier. So we have the hand tracking earlier setup with the synthetic hands and the manual hand ray interactor setup. So I'll disable the manual ray interactors from the hand tracking, and I'll show you how you can add the same ray interactors from the building block. So select the building block menu and you should see something called a pointable item. So if you click on the add there or drag and drop into the scene, you should see that it indeed added a left ray building block and right ray building block along with a pointable item. So the left ray and right ray is exactly the same as of the ray interactor, which contains the same set of scripts, and the pointable item is same as the ray interactable. So it contains the box collider and ray interactable script, which is the same as with our own manual setup of ray interactables. Okay, that covers our ray interactables. Now let's add an throwable item into our hierarchy. So let's add the throwable item building block, and once we do, you could see two more building blocks appearing for each of the hand. One is the grab and one is physics. And let me just quickly position the throwable item. So the throwable item again contains the grabbable hand grab interactable and physics grabbable script, and the physics grabbable reference is also set in the hand grab interactable to allow it to use physics when we throw it. The left grab is similar to the hand grab interactables we added manually. The only thing is that the building blocks component, which shows you all the dependencies are used by, so much more easier to keep track of what are using what components. And the physics contains the same set of script we added to left hand right hand physics. It contains a velocity calculator, unfortunately not the latest one, but still deprecated the standard velocity calculator, and the calculator is also added to the hand grab interactor to use that as a velocity calculator. Alright, now let's see the last interaction item that building blocks has, which is called the grabbable item. You scroll down, you should see that it contains the hand grab interactable and grabbable, but not the physics grabbable, which is required for the throwable item and not for grabbable items. Unfortunately, we don't get any interactions for controllers, so that's the reason I showed you the manual way of adding the controllers and hand interactables. Also, one more thing that you would notice is that unlike the interactor group that we had earlier for our manual setup, the building blocks doesn't give you any game object by default to group any interactors. So you can add them manually if you want them to toggle on and off based on the appropriate grab interactions you are performing. So that's the only difference that I found in the building block. Alright, so we got our interactables working. We could grab it from a distance using controller, and I can drop it anywhere because this is static. So I can also grab it from close proximity, as you could see, and that's also disabling the distant line because the hand grab interactable is taking the priority there, and the interactor group is disabling that. And on the distance I can still see the distance ray or distant line appearing. And this is the throwable physics. I can throw it. Yep, works. Now let's check out the hand interactables. Alright, so this is the static hand interactable. I can leave it anywhere, that will stay. Then I can grab the physics interactable and throw. Yep, and let's see the distance, which again looks really cool with the distant line that we set up. Alright, so you can grab it from any position. So the only reason I added the non-physics is that I can place it anywhere in the air, and I can see I can grab it with a pinch or grab. Alright, and that's how the interaction is set up. Alright guys, thank you for watching this far. If you have, I really appreciate your patience and your enthusiasm to learn VR. And I hope this video has been informational and insightful for you. And if you like these kind of contents, please support by liking and sharing the video, and also subscribing to the channel. That will mean a lot. See you in the next one.